Hi, today we're going to cover lesson 7.5 and we're going to talk about special types of linear systems. On your paper, I have a nice chart. This chart has 3 columns because there are 3 types of solutions. The first type of solution we have already talked about, one solution. That is when 2 lines cross in one location. Happens quite often. But there's also 2 other types of solutions. Another type of solution is when there's no solution. That's when the 2 lines are parallel. Parallel lines will never cross. Okay, they will never cross. And what we like to say is that they have the same slope. That means they go the same direction, but they have different y-intercepts. The third type of solution, infinitely many solutions. That means there are an infinite amount. There's no number for it. The lines go on forever and ever on both sides. This happens when 2 lines get graphed on top each other. They're the same line. Okay, they coincide. Those have the same slope, and they also have the same y-intercept. So there's 3 types. Okay, one solution, no solution, infinitely many. We're going to look at what we will see when we're solving, and an equation may have no solution or infinite solutions. So here's the first example. On your paper, you have 2 equations. 3x plus 2y equals 10. 3x plus 2y equals 2. The first thing I did was I solved for y. 3x plus 2y equals 10. We can subtract 3x on both sides, and then we divide by 2. For the other equation, we do the same thing, but we get slightly different results. For the first equation, we get a y-intercept of 5. For the second equation, we get a y-intercept of 1. So when we graph that, when we graph the first one, we have a y-intercept of 5, and our slope of negative 3 halves means down 3, left 2 to that point right there. For the second equation, we get a y-intercept of 1. We go down 3, right 2, and our point ends up a little further down. But when we connect both lines, they are parallel. Hopefully you would agree that these lines go the same direction. Okay, that means there is no solution. The other thing we could do is we could use elimination. When we use elimination, we would subtract both equations and get 0x, 0y, and 8. 0x plus 0y is just 0. 0 equals 8. That is a false statement. If that is false, we say no solution. So those are 2 ways to show no solution. Let's go to the example on the next page. Example 2. We are going to be looking at a solution with infinite, or a system with infinite solutions. The first equation, x minus 2y equals negative 4. If we subtract x on both sides and we divide by negative 2, we get this equation right here. We'll compare the second one that I highlighted in red to this one that I'm highlighting in blue. They're the same. Okay, they're the same line. So that means infinitely many solutions. The other way we could show that is with substitution. We can set what we see in this second equation into the first equation. We distribute our 2. We combine our x's, and then they go away. And we get this situation where we see negative 4 equals negative 4. That's another way to see infinite solutions. 2 more examples. If we wanted to graph this red equation, we would solve for y, and this is what we get as a result. If we wanted to graph this blue equation, we would solve for y. We get this as a result. When we graph them both, notice they have the same slope that I'm going to highlight in yellow. Yellow is the slopes, and they're the same. So that's why these lines never cross. No solution. This last example, this red equation is already solved for y, and it's ready to graph. A y-intercept of -4, a slope of 2. We could keep going up and over as many times as we needed to make that line. Look at this one that I'm highlighting in blue. If we solve for y, we get y equals 2x minus 4 again. These are the same equations. If they're the same equations, that's when we say infinite solutions, infinitely many solutions. So again, to recap, we talked about the 3 types of solutions. One solution, lines cross once. No solutions, the lines never cross. Infinite solutions, it's the same line. 3 types of solutions. Thanks for listening.